What if I told you your devices are secretly creating their own IP addresses right now? With IPv6's EUI-64 method, your network card's MAC address transforms into a unique IPv6 identifier automatically. But here's the catch. This powerful feature could expose your network if you don't understand how it works. In this video, I'll reveal the step-by-step magic behind EUI-64 generation and show you how to master IPv6 addressing like a pro. Stick around. By the end, you'll be spotting EUI-64 addresses at a glance. Unicast addresses are associated with network interfaces, just like in IPv4. The novelty is that several interfaces can have the same unicast address to do load sharing. Typically, a unicast address consists of 64 bits for the network ID and 64 bits for the host ID. The network ID, in a way, is already affected. However, the host ID can be configured manually or auto-configured. Among the unicast addresses, we have global addresses, which have the same function as public addresses in IPv4. They are routable on the internet. We have unique local addresses that can only be routed within a LAN. They have the same function as IPv4 private IP addresses. There are local link addresses, which are not routable. They allow equipment to communicate with each other without the need to go outside. The advantage of these addresses is that they set up automatically. For example, if you have two routers connected together, well, for them to communicate with each other, you just have to type the command IPv6 enable directly on the interfaces of the link between the routers. And we also have loopback addresses, default routes, and an unspecified address range. As in IPv4, IPv6's multicast addresses are used to join a group of hosts. And we finish with Anycast addresses, which are a small novelty of IPv6. These are addresses which point to a host group, as for multicasts, except that only the first reachable host will receive the data. IPv6 address assignment mode. In IPv4, apart from the static method, the automatic assignment of IP addresses is done by the DHCP protocol. In IPv6, there are several ways, or in static configuration. Either in stateful DHCP, which is exactly the same principle as DHCP in IPv4. Either in stateless DHCP, or it is limited to providing only the options, like the DNS address. Here, the IPv6 address and its default gateway will have to be announced by the router. And we have the auto-configuration mode, where there is no longer a DHCP server, it's the router that gives all the information except for the options. In the last two methods, the PC or any host that will need an IP will receive a maximum of the first 64 bits of the address. That is to say, the network part. He will have to find the rest in two different ways. Either it randomly generates the last 64 bits of its address, or the address generation is done in the EUI-64 format, based on its own MAC address. This allows him to make sure that he is the only one to have this address. The EUI-64 format is a way to form unicast IPv6 addresses. This is a unique method because to be trained, it is based on the MAC address of the network card that is used. So, as a reminder, MAC addresses are identifiers that are unique for each network card. This allows a PC to be able to assign itself a unique IPv6 address, which is a great advantage compared to IPv4, where the PC had to go and get a DHCP server so that they could get one. We will see the complete process of the EUI-64 formula. On the left, we have our network prefix, and on the right, a PC which wants to get an address automatically with the EUI-64 method. To start, you need to combine the network prefix with the MAC address, but add FFFE in the middle of the MAC address. We add our 4 letters because a MAC address is 48 bits, and we need 64 bits to complete our network address. Then, we'll have to reverse the 7th bit from the first byte of our interface ID. The first byte is 00. We switch it to binary, and we reverse the 7th bit. In the example, it's 0, so it changes to 1. Finally, we go back to decimal, and we have our IPv6 address of our PC. This is an address that is very easy to spot with the FFFE field on the 4th and 5th byte of the interface ID. And to finish the course, we're going to shorten the IPv6 address of the PC by removing the 0